Now you can hear they're shouting at me for keeping them waiting for 20 minutes. Okay, so coming back here, so I'll move through it very fast for them to listen. Okay, so here we are going to see a new component, which is the IC L293D. And what's the use of it? To make the motor go right, clockwise, or anti-clockwise. So we have a new component that we see in today's lecture, short lecture, to see how the motor's rotation can be controlled, either clockwise or anti-clockwise. So this device will do that. But inside, what is inside this device? So that we should have an idea, but not like too much, but let's see what is inside. So this is what is inside. It's like a bridge. And now, what is the use of the bridge again? Or what's the use of this? To control the direction of directional control, whether it will go counterclockwise or clockwise. Now, Arduino pins, it can just make the motor rotate, but it cannot control if it goes clockwise or anti-clockwise. Now, as in the simple garage system, we know like motor rotates in one direction, it would either close, and motor rotates in the other direction, it would open. So motor direction is important for most applications. So you see, this shows that the direction control isn't just nice to have, but it is essential for the operations. So we should have a control of the direction of motor's rotation. Now, the edge bridge. How can we form the bridge? By using 4 switches and the DC motor connected in this way. Now, if we close the S1 and S4, motor will rotate in one direction. Now, if we close the other two alternatively, like S3 and S2, the motor will start rotating in the other direction. So, how you control the motor is how you close and open the switches. S1 and S2 makes the motor rotate in one way, and the other one will make the motor rotate in the other way. Now, here in this L293D IC, we are not having switches, but the transistors, and we can still make the edge bridge. So in L293, we have 4 transistors that makes this DC motor rotation control. So this is the name of the IC, and that would make the motor rotate in either clockwise or anti-clockwise. So that's the new thing we are seeing here. It's not just the speed, but the rotation direction. And this is the IC, L293D motor IC. So it's the motor driver. Now, one advantage with this one is that there is a pin of this IC where we can even control the speed. So this IC can even control the speed and even the direction of rotation. So let's just directly go back, like come into the IC, look out. So this is the pin out, yes? So you see how many input and output? Input 1, output 1. Input 2 and output 2. And we have an enable pin for this whole set. And we also have enable 3 and 4, which is for the sets input 4 and output 4. So in this L293D, we can control 2 motors. Because how we will know that? There is enable 1 and 2 for one motor, enable 3 and 4 for the second set of second motor. So with one IC, you can control 2 motors.
Does it have control button?
Yes, it has. So this IC can actually control the speed and the direction of rotation. 2 things this one can. We don't have to write the analog write command. Here we can just vary what we give, like change what we give to this enable pin and control the speed. Let's see how. But you see how many grounds it has? 4 grounds. When you use this IC, all the 4 ground has to be connected to ground. And let's see how we will do that. So enable 1 and 2 we have, as I told, this pin will control the speed of the motor. Enable pin will control the speed of the motor. We don't have to write an additional command. This pin will control the speed. Now, how many motors can this IC control? 2. Now, that's what is written here. First set and second set. First set means what is in the left. The other set is in the right side. So all what is in the left, which is input 1, output 1, input 2, output 2, this whole thing is for one motor. What is like marked with 3 and 4 is for the second motor. First set on the left. For me, it looks like on the left. Yeah, this is right. This is right. It was copy pasted. Okay, this was right. So let's see at the first set. First set on the left, what do we have? Input 1, output 1, input 2, output 2. And we have the enable 1 and 2. Enable 1 and 2 means it enables the input 1, output 1, and the input output second set also. Now, you see we have VCC 1 and VCC 2. VCC 1 means it's powered from the Arduino, and VCC 2 is powered from the battery. We will see what the names are actually. We will come to that. For now, let's see. So this enable pin, as we know, how do we control the speed? By putting in ranges from 0 to 255. Remember? So if you put 255, it's the top speed. If we put like 127, it's the middle speed, 50%. Or we can even calculate using the calculator. You all ask me, do we need a calculator? Why? To calculate the speed, yes. So here we can just directly control what we give to the enable to control the speed. Now we have the input 1 and output 1. These are the inputs, like input 1, we give one input. This we give the second input. Now, you see, if input 1 is high and input 2 is low, the motor will move forward. So we give input 1 high, input 2 low, motor moves forward. But if we make the input 1 low and input 2 high, the other way around, the motor runs backward. So you see what all things this IC can do? Speed as well as the direction control. Feels good, yes? One IC can do 2 tasks.
So for this, we just have to do with the coding part, just one if statement to switch between front, control and backward. That's it.
It's easy. We don't need the if statement. We just have to, can you see? We have to just make the input pins high or low. You see the line which I'm pointing to? We can make them high or low, and the enable pin, you give any value between 0 and 255. So if you give high and low, motor runs in the forward direction with the speed of like 150 digital value. Okay. There is no, if you want, we can, but here it's just like, okay, input 1 high, input 2 low, enable pin, some value between 0 or 255. So just this definition is enough. There is no if. Well, this IC can control the speed by what you give it to the enable pin. That is EN. If you make in 1 high, input 1 high, input 2 low, motor moves forward. Now, if you give like the other case, now how do you move from one case to another? You give a delay. Do this, stop for this much. Now, let's see how it works. Let's move to the code. So you see how I did? I wanted to show this. So, but before that, this is something what I wanted you to guys to see. Whenever I said for some, I didn't set for all. You see, prepare 2 questions on the emphasis of design state code chart. So these are the other works that I do with that. How do you do that? You can create a project. You can drag and drop your files. You can ask Claude to learn, like not manipulate it to do your work, but give your materials to learn from it. It's not like it's having a better friend with you who is more intelligent. It's not like out of the blue you're asking, okay, what is this? It uses its knowledge. But if you create a project, drag and drop your contents and ask from it, it's not using its knowledge, it's using the knowledge that you gave. So use Claude wisely to learn from it. She should have said this before the quiz, yes? I'm willing to give you the quiz again. It's fine for me. If I say like it's most of you, I corrected one paper. I think one student from this side, he's doing very good. I don't know how others would do. So maybe you doubt you. I don't know who gave me. There was a small mistake, but the other, everything is fine. So he's, when I convert back to 4, he's getting 4 on 4. So I'm telling you, if you do bad in the quiz before the class, not during the class session, I will make a session before the class and we will do a short quiz, not during the class time. I'm willing for that. So let me post the marks today. Hopefully by night I will post. And if you feel like you haven't done good, we will see to it. Okay?
Pick the higher one.
Of course, yes. If you do that, you will get high because now I'm telling you how to learn. Let me show you.
One question.
Yeah.
Something this. Okay, if I did maybe 3 out of 4 on this quiz, and the next quiz I did 2 out of 3.
You should aim for higher.
Hmm?
You should aim for higher. You will get more.
No, not the makeup quiz. The second quiz.
Oh no, there is no taking best out of.
No. You're going. If I get worst grade in the quiz 2, if I did the makeup for quiz 1, would I be able to do for quiz 2 also, or only one chance?
No, every exam, if I decide, if it's your right, if the percentage of an exam is about 10, then it is your right to request for a makeup.
So it's below 10, that's why you're
Below 10, then I have to give you the
So
chance.
all of our exams you're allowed to, only the final that you're not allowed.
Final, it's your right because it's more than 30, you can ask. But a student can only ask if it is more than 10%. I hope you know about it.
Yeah. So no, but
Okay. Now you see, oh, my secrets are getting opened. I shouldn't. Okay, so copy paste the lectures. Let me post like 2 or 3. So you will put it here and say, give me questions, guided questions. So as to prepare for my quiz, I expect to get this. Prepare me. Now you're not using the Claude's knowledge and you have to strictly say no hallucinating, which means you have to use just from the knowledge. Learn. I'm not asking or teaching you guys to cheat. Learn. No, don't come like, oh, I don't know anything. This is my first time I'm seeing this. No, learn and come.
In the PowerPoint after the exam, I looked through it
Which one?
after the lesson.
Okay. Sure. So use, I don't tell to use the GPT. I'm telling to use the Claude wisely for learning. You can always question it again because it might not always be right. So you are learning in the class, you know something, yes?
Yes, doctor.
Yes. GPT, I cannot complain of one GPT and the other.
No, you can't do just a chat from the current resources you're providing it, but you need to add some descriptions, some stuff around it. So this one is a lot easier.
Okay, Claude, that's okay. I'll tell the benefits of one rather than saying the demerits of the other one. The other one, well, what's good with this one that I showed is it doesn't keep information to itself. It's always tries to help. So that's what happens in the back of this one. That's how this is designed. Well, for the other one, it doesn't like to give information too much. You ask the same question, give your same material and ask both of them. One will keep information to itself. It don't like to explain too much. The other one will explain to you. So use it wisely for learning. You can always ask it, is it this? Are you sure? Okay. Teaching you. Okay. Now, so for the next quiz also, you have to practice yourself how using that. Now, there is no life without the LLMs now. You are going to move forward with it. So you have to use it wisely for increasing your knowledge rather than that to do your work. Okay, fine. Now coming back. So this is, we are giving it as the setup, and this part we define the pin. You see, we define EN as 11, IN as pin 10, and IN2 as 2. You will do almost the same thing in the lab today, maybe a bit bigger. So it's good to hear than to hear in the lab first time. So we say like pin mode. Here, pin mode means you have to say it is input or output. You don't give the number here. You say if it is an input or output. Well, you can directly put the 11 here rather than putting the EN. You can do this in one step. Well, the right side, you say it is input or output. Now test forward. You see, how do you test forward? You give the IN, which you defined as your output, and you do it as high. IN2 is low, and enable, you said what the speed is. Now, if I delete this much, Control X, so this much I deleted, and if I start the simulation, it will go in one way, one direction only, because IN is high, IN2 is low, and this is the speed. If I increase the speed, it will go at a higher speed. So using this IC, what can I do? Increase the speed, control the direction. That's it. Now the connection. Coming. Yeah, it was moving. You want to see it again?
Oh, the yellow.
This one. Okay, so just going back to connect it, you remember we had the 4 grounds. Always the 4 grounds have to be connected to the ground. Yes. Now the motor. We know that the motor, the positive is connected through a resistor. You don't connect directly. Now let's see what this is. Enable pin. So enable pin, we are connected to the 11, and here we say what the speed is. Here enable is the output, and we say using the enable what speed it will turn. Now we have the 10 and 2. What is it? The input 1 and the input 2. You can use even 8, it's fine. So 11 is to the enable output. All these 3 are defined as outputs. So 11 to the enable to control speed, 10 to the input 1, and 2 to the input 2. So that's what we said here. Now here we have the output. What is the IC control? The IC controls the motor. So it's the output 1. And what's this one here again? Output 2. Yeah, it's not showing. Yeah, output 2. So output 1 is to the ground or the black pin of the motor, and output 2 is to the other end, but through a resistor. And here you have power 1, which is connected to VCC, and the power 2, which is connected to a battery's positive. Now, why? Yes? Okay, if you do that, the motor will run at a very slow speed. It's fine. But to make the motor have more speed, we have to give more current to it. That's why we use a battery. We can connect it without a battery. We can connect directly to the point here, but the motor will run at a slow speed. If you give a battery, it will run at a higher speed. So that's a good question. Now, I will not make you do it. We will try to do it in the next class. And in the next class, we will have the exam. And by today evening, you will get your grades for the quiz that we did today. If you feel you have done bad, let me know, and we will do a makeup, not during the class hours, but like shortly before the class, maybe like 15 minutes before the class. And I hope you will be practicing yourself using the methods. So you won't feel like, okay, I'm seeing this for the first time. Now, coming back to the PowerPoint. So this is the code that we just did. It's copy pasted. I will upload as well. Now, this was your first question. Can we not give to the VCC? But no, if it will, oh, no, not that one, this one. Yeah, what does the 9-volt battery do? It gives a more push to the motor. So otherwise, it would be running at a very slow speed. Now, Arduino cannot run a motor directly. So you remember before we used to, but in the lab, you cannot connect it directly. You had an extra component, I hope, a transistor, yes? You didn't do the lab? Okay. Is the lab assistant taking attendance during the lab?
Yes.
Okay. So yes, so you might be there. So you might have seen the extra component. No, I'm just asking. So you might have seen the extra component. Maybe in the board, it would work fine. But to make the motor run perfectly for the hardware, you need an extra component. That was a transistor. Here you have the transistor, 4 of them coming inside the IC. So you cannot power the motor directly. You need an external component. Now, 9-volt battery, it provides high current to the motor. It would make it run faster. Now, this one, how does the IC help us? IC helps us to control the direction of the motor rotation. Now the last line and we are done. Now, what happens without the battery? The motor would run slowly. So usually, does it work like professional system always have separate logic power? They will have like big batteries or small batteries based on the motor that they are trying to run. Bigger the motor, bigger the power that you need. Now, that's again like you can read through it. So we need the battery to give the motor the extra power, the push to make it run. Maybe it will run here, but when it's in the practical side, as the motor capacity increases, the battery also has to be bigger. That's it. Bye. You don't want to go? I'm saying that's it. Bye. We are done. So next day, we will have the lab. No, we will have the exam. Just a minute, my dear. So we have it from 1:45 to 2:45. 1 hour exam follows the same pattern as the assignment. So you will have the von Neumann architecture, yes? Like von Neumann architecture, like one big one.
First question.
Good question. I'll come to that. So first question is as in the assignment. Like you will have a memory and the address. You might have to do same thing with different numbers. Second, you will have to use the data sheet to write the answer. Remember how you did it for the assignment? You had a data sheet to refer to. So it would not be exactly the same questions, but something you will look into the data sheet and write. Yeah, data sheet is within or in the behind of the question, the exam. It is provided. Question 2 to answer that. Now, how do you know what to expect? As I showed you, put the data sheet in the Claude or whatever GPTs you have, put the assignment question 2 and ask it, what can I expect from this data sheet similar to the questions that I have? So you will get like multiple, it will generate like, it will be happy to generate for you. So look through it and see what all kind of questions you can expect. Third one, it's not going to be that difficult as you saw in the assignment. It is not that difficult. So something just before that, look, you have to write the code by yourself. It depends on the whole code or the whole code. it will not be that long, but it would be long. You will have the void set up. You would have the void loop. Okay. But it will not have so much of conditions. I can assure you that. It's doable. It's not the traffic light, the last question, where you have the last 3 lines. You remember I said it's the additional line which makes you switch from one case to the other. Blinking, yeah. So, yeah, some kind of blinking question it is. You can study the code from the lecture slides, like lecture notes or the slides that is given in the class. Every time you study writing the code, go in the Tinkercad and type in and see. Circuit is hand-drawn. State diagram is hand-drawn. Code is handwritten. Okay. And in the beginning of the data sheet, you have the pin diagram as well. There is no one-word question. There is no multiple choice. It's like in the assignment. You will be able to.
Still depends on people. They are going to talk or not.
I think, I don't know. I'm not going to change. Let's see how it will be. I'm not mean. I don't want to be mean. Okay. I was sad. I was sad. Seriously, I was sad. But now I'm not. There is like so much other things to be sad about. Yes, this is not going to affect me. And you. Nothing is going to change. I'll bring exactly the same thing. So it all lies in the, what you say, it all lies in your feelings, and it all lies in how others treat you. So for me, I'm not going to be affected. They are also not going to be affected. I forgot what happened. Everything is good. Let's see. Okay. But as far as you know, it's a life lesson. Like you are not supposed to touch any other things, even if it is something that you like. That's it. Bye. You have to run for your labs.
Doctor,
Yes.
you said that the exam will be similar to the assignment 2, right?
Assignment 1, my dear. We have only one assignment.
Okay. We thought because you said by mistake maybe assignment 2. Okay, one more question.
Yes.
We only draw and code. No essay questions. No multiple choice
No,
questions.
no. First, you will have the architecture, like the memory and the address. Then you have something that you look at the data sheet and write. And then the third question, like the state diagram, the circuit diagram, and the code. That's it.
Okay. Thank you.
Thank you. Bye.
And
Doctor,
one more
the
thing,
TQ will
doctor.
be, yeah.
Doctor.
Yeah. Yes.
Actually, some of student, me and my colleague, we are in a line. We have another exam at same day. So if it's possible to extend the exam for us on next Thursday, Tuesday.
Yeah, like what is that this is all done by accepting in the system, and even the TA is assigned. So it's all going through the administration as well, and now it's difficult to change in the last minute.
Okay, thank you,
So we
doctor.
have to go through the same time. I'm sorry.
No, it's fine. I'm just asking for possibility.
Yeah, I understand. Okay, dear. Thank you and all the best. So I will stop sharing and I'll leave the meeting. Bye. All the best. Bye.